Good morning, good afternoon. Welcome to everybody to this webinar. Welcome to this webinar about our flow monitoring system for cooling channels. I'm Anjum Parvais, Global Sales Manager, and with me is Murli, who is our product and support. The first webinar about the flow monitoring system. There will be another one after the summer. And in this webinar, we will show you the user interface and software and how the flow monitoring system is used. I'm here in the factory area. I'm standing in front of our demo box or replication of our injection molding machine, onto which the flow monitoring system is installed. You can see down here the components of the flow monitoring system, which consist of manifolds with inbuilt sensors. We have a power supply, we have a PC, a computer, a server, and an input-output units. You can see the sensor here, and you can also see the cables that connect everything together. Also part of this is a 15-inch touchscreen monitor, if you want to have a standalone unit on it. But in this box, you can see the manifolds are installed on the injection molding plattens, left and right side, moving side, fixed side, and the hoses that supplies the cooling water is connected, both inlet and outlet, to the manifold. Down here, you can see the control panels. That's where the power supply and the server is installed, and everything is connected with a serial communication cable to each of the manifolds. The flow monitoring system is designed for a permanent installation on the injection molding machines. However, for some customers who have many older machines who do not want to have a permanent installation on the machine, we also have a cart system, which is a mobile unit where the flow monitoring systems and the components, including the touchscreen, is installed. So it can be moved to the machine, plugged in, and then you can do the flow monitoring system for a set period of time. But we will go more into details in the second webinar about the compositions and how they are installed on the machine, etc. The purpose of the flow monitoring system is to real-time monitor the actual flow temperature, flow rate, temperature, and pressure conditions of the cooling channels. The purpose is also to you can also set the alarm limits for the desired flow and temperature of the cooling channels. And with all these insights, it is possible for you to troubleshoot to find the root causes for any alarms. And it's also possible for you to optimize the cooling time and cycle time. Briefly, the agenda for this webinar. Today, we will talk about the user interface and the software, and we will walk you through how to navigate in the menu of the software. We will show you how to configure a manifold to the system, to the machine, and we will show you how to set and monitor changes in the alarm limits that you set by yourself. We will show you how to monitor any changes of the measured parameters when the machine is in operation, and we will show you how to configure the flow monitoring system. We'll also show you how you can see the system data and how it's possible for you to export them. And finally, we will also show you and tell you how it's possible for us to remotely connect to the flow monitoring system so that we can provide you with training or any support, remote support. We will end the webinar with a Q&A session. So we hope very much that after this webinar, you will know all about the configuration and setup of the flow management system, and that you'll be able to monitor your cooling channels and share the data through either USB or onto your local area network. So I think we should, with this introduction, let us begin, and I will give the words to Murli.
Thanks a lot,
Murli, can you please walk us through? Thank you.
Thanks a lot. My name is Murli. I'm responsible for product and support activities here at Mouldflo. I shall walk you through the Mouldflo monitoring solution, which Anjum just touched upon just earlier. And let's start. Now, the screen that you see in front of you is the Mouldflo monitoring solution home screen. And this gives you an overview of all the connected manifolds that you have hooked up to your injection molding machine. The software that you see is a demo version of the software that we have. This is just for demonstration purposes. So this is the home screen wherein we have four manifolds connected. It is manifold 1, 2, 3, 4, and we have different manifolds of different sizes. And you can see there are four circles on the top row, meaning that is a four zone manifold or a four channel manifold. And similarly for manifold 2, you have 8 circles, meaning it's an 8 channel manifold, and likewise for rest. So the manifolds 3 and 4 are 12 channels. So from a home screen, you can see the statuses of all the connected manifolds, or rather the mold cooling channels from your home screen itself. So we have different different activities going on in the home screen, but I'll come to that a little later. First, I'll just walk you through the different menus in the monitoring solution, and then we'll talk about each and every menu a little more in detail. So this is the home screen that you see with the monitoring solution, and here's you see the basic statuses of all the connected manifolds that is connected to your system. And you can see there are three icons in the bottom right corner of your screen, and the left icon in the bottom right corner, that is the setting screen wherein you configure the Mouldflo monitoring solution before you do any changes with the manifold or before you configure the manifold. This is the first settings that you need to do when you boot up our system, which is the general configuration. So you can choose the language, the units you like to use, set the appropriate times based on your time zones and stuff like that. So this is the first screen that you would like to go into and make the settings based on your requirements. And there's an icon besides that, that is the system status and logging screen, wherein you see the system status and the system logs of what is happening inside our monitoring solution. The icon on the extreme right towards the bottom is the exit icon, or rather the restart icon, wherein you can restart the software should it should you face some issues with the software and you think that it is necessary to restart the software. On the top, you see an icon called a screenshot icon. This is used to capture screenshots of the screens for troubleshooting activities, or if you have some local reference and store some reports locally, you can use this icon to capture screenshots of the particular page in the monitoring solution. The icon on the bottom left is the super user icon, or rather the logout for the super user icon. So by default, you log in as a super user, meaning that you are the administrator for this software. And by administrator, I mean that you can make changes and edits to your mold cooling circuits with regards to limits. So that only certain authorized person would be able to do that. All other factory floor members would not be in a position to do that if they are not part of the super user group. So this is an icon to come up out of the super user group if one were to click on it. So this is the basics main settings page of the monitoring software solution. So I'll go back to the home menu. So here the home menu, it shows you the overview of all the connected manifolds and their statuses. Now you see a lot of green, red, and yellow dots. I'll come to it a little bit later, but this is the status. A green means, just in a brief, green means all system parameters within that cooling circuits are okay. Red means there is some issue with the cooling parameters. Yellow means it's going to go into the red territory. So at a glance, you can know how your manifolds are performing. And from the overview screen, I can easily figure out that the manifold 4 has no issues whatsoever. But all other manifolds, manifold 4 and 2 has no issues whatsoever. But manifolds 1 and 3 have some issues. So it gives me in real time what is happening inside the mold cooling circuits during production. So if, for example, if I want to know more about one of these particular manifolds, then I just click on the manifold names on the sidebar. And when I click on the manifold names, it gives me a detailed overview of all what is happening inside the manifold circuits. And this we call it as a manifold overview screen. In the manifold overview screen, we get all the different information with regards to the manifolds, like the temperature, the outlet temperature, the flow, the delta T, the Reynolds number, and pressure if pressure sensors are enabled. And you can see there's three icons at the bottom. The leftmost icon at the manifold level is the manifold overview screen. The middle icon is the same view but in a timeline based manner. So it will show you the flow and temperature parameters for the last 5 minutes or last 50 minutes. So in a sense, you can monitor how the flow and the temperature trend has been in your cooling circuits for your entire production processes. So if you find any deviations in your mandated flow or temperature, then you can immediately stop production and do corrective actions. So this is the flow and temperature information in a timeline based manner, so that you can be always sure that during your entire production processes, the flow and temperature parameters of your cooling circuits are always under control. And there's a third icon in the bottom right corner is a spanner icon, a gear icon. So if you click on that, this is the configuration page wherein you configure the different manifolds that you have connected onto your injection molding machine. So these at a brief are the different menus in our Mouldflo monitoring solution. So these are the different menus. So we have the menus pertaining to the manifolds and the menus pertaining to the general layout of how do you want to use the system. So the first thing that you do once you connect our manifolds onto the system is like the manifolds will automatically pop up once you have these connections made into our software and booted our software up. But then the manifolds won't be configured. As a first step, it's the operator's workflow procedure to configure those manifolds and ensure that these manifolds are set up in a right manner. In order to do that, once they connected the manifolds and booted the system, they will see all the connected manifolds here in the home screen, but they have to configure that. So they go into the manifolds page, then go into the gear icon, and then here they will find the layout of the manifold configuration. So in this, it is very important that they have configured the hardware configuration as is, coolant configuration, and the channel limits. The first thing that they need to ensure, because it will be set automatically, but in order to be double sure, they need to ensure that the hardware configuration is correct, meaning that the channel sizes of the manifold they are ordered reflects the channel sizes shown in the software. So for example, they have ordered a 4-channel manifold, so it should be set as 4, and they just need to verify that it is set as 4. The next thing that they need to set is the correct sensor type. So we have three different sensor types, which is 1 to 15 liters per minute, 2 to 40, and 1 to 20. So they need to set the appropriate sensor type that comes as standard with the manifolds when they place the order. So that they need to set it manually, because if the sensor type is incorrect, then they will not get the correct information with regards to flow. The third one, they also need to check, it will be set automatically, but they just need to verify whether the pressure sensors are enabled or not. Because the manifolds comes with the pressure sensors fitted in, it will be enabled automatically. They just have to check it physically and see that it is reflected in the software point of view also. And the last thing is the channel reverse. This is the new thing that we have incorporated in the new version of the MFS software, wherein we can reverse the channel numbering of the connected manifolds. For example, all our manifolds, when they are mounted from top to bottom, are numbered from top to bottom, from 1 on top and 4 at the bottom. But if they want to have two manifolds side by side each other, then we can inverse the channel numbering, wherein the bottom-most channel is the channel number 1 and the topmost channel can be channel number 10. So we have ensured that each manifold can be configured, or the numbering on each manifold can be reversed based on the orientation of the manifolds. So these are especially useful when the manifolds are mounted right besides each other.
Mhm.
One in a top to bottom fashion and the other in a bottom to top fashion. So these are the first things that the operator needs to be aware of while configuring the manifolds. So first, he has to make sure that the hardware configuration with regards to the channel sizes, the sensor types, the pressure sensors, and channel reverse feature are enabled based on their requirements, and are they proper or not. That's the first thing that need to check. The second thing is the coolant configuration. We support a mixture of glycol water coolant configuration, but they are not sure of the coolant configuration. We just treat it as water. So if they are not using a particular mixture of glycol and water, they can just leave it as is without making any changes to this. The other one is the channel limits. This is an important thing because the thing is you want to monitor the channel flows and temperatures. So you want to see that, okay, I have a current flow of 4.9 liters, and I want to make sure that the flow always stays in this range. So if I want to do that, I can just set a lower limit so that the lower limit says, okay, I want the lower flow of somewhere between 3 liters and an upper flow of somewhere between, yeah, 6 liters or something. So here I need to set the limits. So by setting the limits, I would know that my flow and my temperature, you can also do the same thing with your temperature. So my flow and my temperature for all the cooling circuits are within specifications that I mandate it to be. So we have three options of setting those limits. First is the called customized options, wherein we can feed in our own mandated higher flow and temperature values, and higher flow and limit and lower flow and temperature values. But you can also set templates wherein you can see we can just run some flow through it and then say that, okay, this is the optimal flow you want. Then if you can just set the template, auto templates, then it will automatically fill in the lower and upper limits based on your current flow values and current temperature values. With current flow values, it will be plus or minus the current flow, and with temperature, it will be plus or minus the current temperature. So if I go to the temperature tabs, all the lower and upper limits will be changed accordingly. So we can also set some templates so that it makes our lives pretty bit easier to set those limits, and we are always sure that these are the limits that we always track. So if you want to track all the channels, you just enable all the channels, and then you say, okay, this is what I want to track, and these are the flow ranges that I want to track, and these are the lower and the upper limits which I mandate the flow and the temperatures should be at always during production. So
So
this is
Murli, if I can just add on, so what you say is that these channel limits that you set, these are basically the alarms limits that you're setting. You want to have a particular flow or temperature which is optimal for your cooling time and cooling cycle time and cooling time, and then you do not want the flow to deviate within an upper or lower limit. So this is what you're setting here: an upper or lower limit. If the flow or the temperature crosses that these limits, then there will be an alarm.
That's precisely, yes. So the idea is like it will give the user a reference, a lower boundary and an upper boundary for both flow and temperature. So if, for example, as an example, if the user wants 10 liters of flow, then it is based on the user. If the user wants 10 liters, you can set the lower limit to be 9.5 and the upper limit to be 10.5.
Mm.
So, and he always ensures that the flow is always stays between 9.5 and 10.5. Of course, it depends on how much error deviation the user is okay with for the particular process. So that is subjective. So this is up to the user how much error deviation they can handle for a particular coolant flow and temperature values.
Or you could say how much they can accept.
Yes.
Super. Murli, what about the diameter measurement?
Yes, the diameter measurement we'll just use. We also, if you come back to the screen,
Mm.
in the overview screen, we see a number called as a Reynolds number. This Reynolds number is a key factor in heat dissipation. So we always recommend a Reynolds number greater than 4000, meaning that the flow is always turbulent. And the Reynolds number is determinant on a lot of factors such as the velocity of the coolant water, the diameter of the channel size, the temperature of the coolant water, and the kinematic viscosity of the coolant water. And in order to find a good ballpark value of the Reynolds number, it is necessary that we give the channel diameter size of each cooling circuit. So if we give the correct channel diameter size, then we can also add that in the calculation of the Reynolds number math. So you get the best possible value of the Reynolds number. So for the calculation of the Reynolds number, we use the diameter of the cooling circuit.
And this is a value that the user have to input and verify for each of his cooling channels.
That would be correct. It's up to the user to ensure that they feed in the correct values for the diameters. And it's not, if they are not worried about the Reynolds number, that they need not worry about feeding in 8 values with the diameter. It's just an important parameter when they are very interested in the Reynolds number math. So assume that we have set the channel limits, the coolant configuration, provided you have it, and the hardware configuration. You can also change the names that best reflects the mold name. So suppose you have two manifolds, one manifold for the fixed half of the mold and other manifold for the movable half of the mold. So we can just rename it as mold name hyphen fixed half and mold name hyphen variable half for each of other manifolds, and then you can save it. So we can save individual manifold configurations. So if you want to cycle through different molds, we can load different manifold configuration that is applicable for that particular mold. That's why we have features to both load and save manifold configurations. This is, you save each manifold configuration one at a time, but later we can also show you how we can do it for all the connected manifolds in one shot. So you can also save the entire manifold configurations. For example, in this system, there are 4 manifolds that are connected. So you can save all the 4 manifolds that connects to the same mold in one configuration, and then we can cycle through that configuration. So for example, for one mold, you use 3 manifolds, for other mold you use 4 manifolds. So you can save these manifold combination of manifold configuration is a single file, which we'll show you later. But for now, just please be aware that we can save individual manifold configurations if we want to keep this process very simple. So we have if you have connected these manifolds to 2 different molds, for example, so something like that. So this is the first step that you have to do when you configure the manifold. Once you do that, if you go to the overview screen, you have the limits that you have set as black and gray markers. The gray markers is the warning limit and the black markers is the red limit. So if the flow or the temperature were to go beyond gray, it will be yellow in color, and if it goes beyond black, then it becomes red in color. Now it is green, meaning that both the flow and temperature are within our specifications. So that's that. So we also show the flow, the temperature, the delta temperature, and the Reynolds number. The Reynolds number shows the turbulence, the amount of turbulence the flow has, and more the turbulence, the more the heat dissipation you can expect from the cooling circuit. Delta T is nothing but the temperature difference between your inlet temperature and your outlet temperature,
Inlet temperature, which is stated in the bottom of the screen.
which is stated in the bottom of screen. And then you have the outlet temperature of each cooling circuit also. And if you go and the next screen is the overview screen, you can see all the flow and the temperature values for, say, I want to see for the past 5 minutes whether they're stable or not. I can just see that. So here maybe the flow is different for each channels because it's a demo software, but I can track it. And if I want to have, if I have more channels, right, so then I can see whether all my cooling circuits are within spec for the last, say, 40 minutes of production. So there are no major deviations. So this is the channel I want. This is the channel flows I want, and this is the channel temperatures I want. So the channel temperatures are fairly constant for the last 40 minutes. So that's good for me. So you can get an overview. Maybe the flow is not, so I need to stop production. So it gives you an overview of how your production processes cooling parameters have been for the last 40 minutes. And you can also do the same for up to 24 to 48 hours of your
mm,
production.
mm,
And you can also zoom in if you want to have more granularity of data, and then you can also reset the zoom. So this is the same measurement information, but in a time-based manner. And you can always ensure that during an entire production, your flow and cooling parameters are within specifications. So the most screens, once you have configured the manifold, is to shift back and forth between the overview screen, which tells you whether it's alarms or not, and then the graphing screen, which tells you whether your production processes are within spec all times or not.
mm,
So this is your the basics information about the manifold. How do you configure the manifold? How do you use those information in the manifold, both from a real-time point of view as well as from a historical point of view? So that's the part that we have covered about the manifolds. Let us go back to the main screen. And here in the main screen, it gives you the overview of all the connected manifolds. And in the main screen, as I've already mentioned, we also have certain configuration parameters that you can do by clicking on the spanner icon here on the main screen as well. Here you can set the network settings. So you can connect the MFS, which is the Mouldflo server, which runs this software, to your local area network, and it can directly connect to any DHCP server and get the appropriate IP of the local area network, and you can connect it, or you can set it as a static IP and make it as a standalone system. So you can give the network settings here, configure the network settings here based on your requirement. And there are also other settings that you see as system settings. The first one is the virtual keyboard. So we have an option of providing you an on-screen keyboard. And if you don't want an on-screen keyboard, you can also connect the USB keyboard onto the MFS, uh, to one of its USB ports onto the MFS. You can also change the language. So we have certain languages like Spanish, French, German, Japanese, Polish, Turkish. So you can also change the languages, and you can also create new languages should you need it for your localized time zones. We also support two types of metric system. One is the metric, another one is the imperial system. So metrics means the flows is in liters per minute, and temperatures in degrees Celsius, and pressures is in bars. And imperial is flows is in gallons per minute, and temperatures in degree Fahrenheit, and then pressures in psi metric, psi units. Export duration. You can also set the export duration. And export duration means that you can set how often the measurement data, like the data pertaining to flow, temperature, and pressure, how often they are stored on the MFS. The MFS comes with 11 gigabytes of onboard flash memory. So if you were to set it at 30 seconds, you want to save all the production data. Consider your production were to run 24/7. Then you can have data, historical data up to a year. But if you're okay with storing data and average data, only one sample every 5 minutes or 2 minutes, you can have a couple of years of production data or historical production data. So it's up to you how much granularity you want to have, how much historical data you would like to store in the system. So based on your requirement, you can set the appropriate export duration, meaning how often the real-time data are stored in the system if you want to export any historical data and view trends. The other option we provide is to set the date and time. And of course, this is the first thing you should do once you receive our unit is to set the date and time. When we ship the unit from our factory, we make sure that it is set in uh, European time zone, Central European time zone. But when you receive anywhere in your world, you have to set your local time zone. We also have two more features which is called system idling feature, which is nothing but you have now set the limits, but for maintenance reason, you want to make sure that you are not triggering alarms because you are well aware that you are in your maintenance phase. So if you are in maintenance phase, you can just turn this on and then you can do maintenance. So if the flow or the temperature limits were to go out or go off the limits, then it will not trigger the alarm. So once you are done with maintenance, you can just turn off the idle mode and then it will monitor for alarms again. So system idle is nothing but the system will idle around and will not monitor for alarms. And you can just use this feature if you know that you are in a maintenance phase wherein you don't want unnecessary alarms to be triggered until and unless the maintenance is complete and it's in production. The other option, the last option in the system settings is called UAC, User Access Control. And this is nothing but password production to your mold configuration. So if I go to the settings screen here, so if I log out, now I'm not a super user. I just go in the manifold configuration screen and then click on the gear icon. It will ask for a super user password. So here I need to enter my password, and without entering my password, I cannot change the mold, or rather the manifold configuration that connects to the mold. I cannot change that. So it's only a super user can set and change those configurations. So it is just a security feature that we have implemented, that not all people in the factory flow can play around with the settings. So once a super user has set this particular limits, no others can do that. So once I set it, I cannot change it. So I can just log out, and then others who just use the system cannot go in. So if you think that it is not needed, user access control is not needed, you can just turn it off. So it'll just ask for a password. So you can just give the default password, which is 123456, and then we can just turn it off. So now it will not ask for a password. If you go to any screen, it will not ask for the password. So it's up to your requirement whether you need to have some kind of a password control to your mold configuration. The last part that we cover with regards to the configuration is saving the mold configuration. Please remember that when we dealt with the manifold configuration page, I told you that we can save the manifold configuration by load and save. You can save individual manifold configuration. But just consider this scenario wherein we have four manifolds connected to a particular injection molding machine. In this case, I would like to save all the four manifold configuration in one shot. So in order to do that, I will go to the home level settings page, and then in the files and configuration, I'll just save. If I click on save and give an configuration file name and then save it, what it will do is that it will save all the connected manifold configuration. Like it will say the manifold configuration for manifold 1, 2, 3, and 4 in a single file. So if you have if you configured manifold for a particular molds, then you can easily cycle through the molds because you can set various parameters for each of those manifolds for various molds. So it'll be easy for you to cycle through already used molds again with minimal effort. So that's why you use these features of loading a mold configuration and saving a mold configuration. By mold configuration, we mean all the connected manifolds that connects to a particular mold.
And this is actually a very fantastic feature because that means that when you then install a mold again, you can just load the configurations that you have already saved. That means that the startup time is very, very fast.
And now we'll come to the data feature of that. With regards to the data, we have two options. You can export to a USB. You can connect a USB stick onto the Mouldflo system and then export the measurement data. I'm not talking about the configuration data, but rather the measurement data with regards to flow, temperature, and pressure of the cooling circuits historically. You can export it onto USB, and it can be exported like an Excel file which you can see, and then we can plot charts and trends. You can export it to an USB or to a shared drive if you are networked onto a local area network. We also provide support for additional language packs. And should you run out of space, then we also have an option to purge the data. So this will ask whether you want to delete the data so that you have some space. So you say, okay, I have like 2 to 3 years that I don't want, so I just want to delete it and start afresh. You can just do it. So we also
So
have,
this so
yeah,
this way you can free up the 11 gigabyte space.
that's correct.
Uh,
So these are the main configurations that you can configure once you receive the box, like configuring the language, the measurement unit, the time, whether you want user access control, and how often you want to save the data, and whether you want to connect our system to your own network or have it standalone. So all these configuration information, you can set it here before using our system. And the final part I will just touch upon is the logging screen. So let's assume that now you have connected all our manifolds. This screen shows the status of all the connected manifolds. So if there are 4 manifolds that is connected, you should say OK on all these 4 manifolds. If it doesn't say OK, then you have to check the cables and connectivities and see whether the manifolds are connected properly, they are tightly secure or not. So this will help you to troubleshoot should you face any issues with connectivity problems with our manifolds. And if you click on the other tab, this is the logging tab, it also shows you real-time logging data. So if you have any issues, you can just take a screenshot of it and then talk to support, and then it will helpful for us to do troubleshooting of any software or system related issues that you might face on the field.
Murli, maybe you can show how to take the screenshot, for example, of this
Yes,
and how
yes.
to save it.
We have a USB key plugged in, and then if
Mm-hmm.
you want to take a screenshot of this screen, so you just
Mm-hmm.
go to the particular screen, have a USB key plugged in onto the device, click on the screenshot icon, a USB drive will pop up, and then you can just select that USB drive, click a file name, give a file name, and then click on save. That will save the screenshot of this particular screen onto the USB key. So that's it.
Okay, but you can also save it on the local files shared on
Uh,
the system itself.
we have not made it saved in the local files because it is usually done to share something with us. So they usually
Perfect.
use it on the USB and then directly, yeah, connect it to your PC and then send it as an attachment to us via email. So
Super.
we just said that it makes sense to save it on an USB rather than internal storage.
Sure.
So this is a basic overview of the monitoring solution. So just to give you a brief recap, we talked about the home screen. We talked about the home screen and the main software configuration. We talked about the system status and login. We talked about uh, individual manifold configuration, manifold overview, the graphical overview, and we also talked about all the features that comes like data export feature, language feature, mode cycling feature. And yeah, this gives you a brief overview of the Mouldflo monitoring system. And
Super.
one final thing that we like to touch upon is regards to support. So if you have connected our system to your local area network, and if you give VPN access to your local area network, then we can also VNC to your device and help you in any kind of issues with regards to our system or mold cooling circuits in general. So
And that you can do by you need to install a fixed Ethernet cable to to the server to the MFS, and then we can connect. Is that correct?
that would be correct, yes.
I wonder if you could also show how to load a manifold,
Yes. So, I mean,
and
if
also
you,
how to rename, for example, if you want to change the name of a manifold, You touched upon it, but it could be nice to show it as well.
Yes, you can just say I would just rename a manifold like mold.
Now you're using the online, you can say on-screen keyboard, but you can also use your keyboard.
Yes, you can also use your keyboard. So I'll just for simplicity, I'll just get mold fixed start and then save it and save it. So you can just save it in a different configuration file, and then we can just load in the different configuration you like to
Hmm.
have. So you can just do that. So and one thing is like you can do the same if you want to save the entire manifold configuration. You can just save and give a file name like some file name and then save it. The entire configuration that will be saved, and you can
Okay.
also load it. So yeah, it's pretty seamless. So if you're working with a lot of different molds, then you can just save these mold configurations onto your file and then reload them back if we are cycling through previous molds. So the setup of the mold, once you know the cooling parameters for each mold and the ideal temperature and the flow circuits flow parameters you want for each circuit, then you can easily cycle through the molds without any issues. And the thing to be noted here is that we have in our chain, we have from the manifolds we connect to a Mouldflo input output interface, and from the Mouldflo input output interface we connect to the Mouldflo's PC where our software runs, and then that PC connects to a touch panel wherein you can see the display. So the thing is, on the Mouldflo input output unit, we have some relays that you have given marked as alarms. So you have to connect your factory beacons to those relays so that the software triggers those relays, and when the
Hmm.
relays are triggered, it will activate any connected alarms that are connected to those relays. So just for your information that whatever alarms you see here, it's just a triggering of the relay on the Mouldflo input output interface, which is attached on each and every injection molding machine as part of standard installation.
And just to add on to this, so the flow monitoring systems can come as a standalone unit where you also the 15-inch touchscreen is part of the system. But the flow monitoring system can also be installed on the machine and then integrated into the machine control panel through a VNC connection or through OPC UA, correct?
That's true. So we have a couple of integration options. One is, as Anjum said, we have the full-fledged with the entire thing with the touch panel. We have direct integration if you want to play around with the raw data and not processed data. And then because of data security issues, you want to have just raw data and you do your own math and software on top of the raw data and then consume that data to your further downstream equipment. The third one is through VNC, wherein you want to integrate our screen into your VNCs, into your injection molding machines interface. So that is, you don't want to go back and forth between two screens. Just want to have it in one screen that comes as standards with the injection molding machine. So we support VNC, and that's a standard protocol that most injection molding machine user interfaces support. And through that, we can connect to our interface. And the last one is the OPC-UA, wherein it's for direct machine-to-machine communication, wherein you want to have our cooling parameters into your MES device, for example, for further automation and full overview of production processes. So we also support that.
Super, thank you very much, Murli. I think it was a very good and comprehensive walkthrough of the flow monitoring system user interface and software. Then I would like to end the webinar. So this was the first webinar about the flow monitoring system and how I just briefly showed how it's installed permanently on the injection molding machine, and it can also be used as a mobile device. In the next webinar, as I mentioned, we will go more in details about the different components of the flow monitoring system and how they are connected together and how they're installed on a machine. But for this webinar, I hope that you found it beneficial and valuable. And of course, you are most welcome to contact us if you have any questions. As a conclusion, I can say from the many thousands of installations of Mouldflo flow monitoring systems around the world on all types of machines and molders, that we can see it's, the flow monitoring system is an extremely valuable tool for molders. And no matter the type of production, whether they're medical, automotive, packaging, electronics, buildings, etc., etc., the flow monitoring systems helps get a precise and real-time insight of the cooling processes, and helps tells how effective the heat transfer and heat removal is from the cooling channel. And it also helps troubleshoot where and what the problems are that have caused the alarms. Is it scale? Is it rust? Damages inside, and so on. And it helps secure a faster startup of the production, because you have already saved and found the optimal cycle time and flow rate and temperature and so on. So these data can be saved, and when you start up the mold again, the configured data can be reloaded, and then you can immediately target these settings, and to ensure an optimal cooling time, and by that also the cycle time, of course. So better knowledge and insight leads to better control. So with these words, thank you very much for attending this webinar. Wish you a very nice day, and look forward to see you again on the next webinar. Thank you.